Good afternoon. This is John Sprovieri, Chief Editor of Assembly Magazine. Welcome to our latest webinar, E-Mobility, Solutions to Meet Screwdriving and Assembly Challenges. This event is brought to you by Assembly Magazine and sponsored by DEPRAG, the leaders in automated screwdriving technology. Wherever and however you are watching, we thank you for joining us today. Today's presenters are Boris Baumler and Daniel Gutenberger. I've known Boris for years now. He started his career at DEPRAG in 1986 and has held positions as Service Manager and Senior Applications Engineer. And he is currently Vice President of Technology, overseeing all of DEPRAG's North American technical operations. Daniel is likewise a longtime veteran of DEPRAG, having started in 2003 as a technical product designer. Now, this is a live program, folks, so please do submit questions for our speakers. Later in the program, we will address as many as possible. Today's event is being recorded and will be archived on our website, assemblymag.com. And now, without further ado, I'm excited to turn it over to today's presenters, Boris and Daniel. Take it away, gents.
Thanks, John. So assembly solutions for e-mobility. E-mobility brings many new requirements to the assembly processes. High process reliability for many safety-related components. High flexibility due to wide range products and many application variations, along with many requirements for manufacturing data traceability and ESD validation of system components. In addition, these components require an assembly environment which satisfies the guidelines of technical cleanliness for manual operation considerations, are ergonomic, and safety aspects. The complexity of these different tasks can be a challenge to a budget-friendly approach. DEPRAG has innovative assembly solutions to meet these requirements, brought to us by e-mobility these days. So some key components for e-mobility are body in white, related structure components, commonly with new and dissimilar materials, aluminum, high-strength steel, and carbon fiber composites, train components relating to electric motors, gearboxes, and drive axles, battery pack assemblies, and battery pack enclosures and structures, control and power electronics, inverters, onboard chargers, battery management systems, and various ECUs, sensors, and actuators. NEVs are made up of many unique and complex assemblies. Unlike traditional vehicle design, many more are produced offline or by sub-suppliers and later joined to make a finished assembly. In this presentation, we will focus on just a few of these. Daniel will now tell you a bit more about some of this.
Thank you, John and Boris. I would also like to extend a warm welcome to you all, and many thanks to the Assembly Magazine for giving us the opportunity to deliver this presentation. Like John mentioned, my name is Daniel Gutenberger. I'm the product manager for fastening and feeding technology at DEPRAG, and I'm located at our headquarters here in Germany. So, assembly components, the challenge. Usually the screw joints of the category A, in accordance with the VDI standard 2862, are used for the assembly of elements in the automotive industry. Process reliability is of utmost importance, and all processing steps must be documented and monitored. The assembly process for battery module or power electronics with a wide variety of components is highly complex. Numerous screws must be assembled in the correct order to guarantee a consistent preload force. Within a lightweight construction, especially in the field of e-mobility, aluminum or lightweight metals and synthetic materials are increasingly used. Widely varying torques are commonly a result of the frequently employed direct assemblies. Due to different material characteristics, settling conditions can also vary. As these are predominantly conductive connections and conductivity must be guaranteed, adaptive screwdriving procedures are recommended for reliable detection of the seating point. Boris, can you give our guests here a deeper view into this topic, please?
Yeah, so considering the application itself, gaps between a screw head and components, leaving it loose, or with an improper electrical conductivity. Open circuits, resulting in part failure at final testing. Partially open circuits, resulting in dangerous arcing and premature product failure in the field. And seals not fully seated, resulting in corrosion, which may not become apparent until in use in the field. These are concerns that has always been in place, but have become more prevalent with the EV assemblies. If created by a questionable design, there's many designs that are speeded through the process with many of the startup EVs, a faulty screw or part, or possibly a part manufactured by a sub-supplier. The problems can result in the same. A screw not driven properly, possibly just slightly loose, but a problem. All this results in lack of productivity, rework, increased manufacturing costs. So Daniel, what can be done during assembly to prevent this from becoming a faulty problem?
Yeah, so how can we guarantee the screw is fully seated to avoid the problems Boris mentioned in the previous slide? So if we use just the tightening strategy, fasten to torque, we cannot guarantee the screw is 100% seated, because torque can increase because of other conditions like a damaged thread or a wrong dimension of the hole in the part. So the solution here is our tightening strategy called clamp force control, or CFC, which allows an automatic seating point detection, which means the software detects the point, like you can see here on the slide, the highlighted point, the so-called seating point, automatically without any high complex parameterization. This ends up in a more constant preload force when we talk about direct tightening or self-tapping screws. Another advantage of the clamp force control strategy, which came up for the assembly in e-mobility, is that we can make sure we have an electrical contact, which is, of course, very important for conductive connections. So let me give you a brief insight how to parameterize this strategy. So the parameterization of our tightening strategy clamp force control is pretty simple as mentioned. So you just have to fill approx 8 parameters, which are, for example, the limits of torque and angle of rotation for the seating point, to avoid a wrong detection because of, let's say, assembly conditions which are completely out of the normal screwdriving or tightening process. The less amount of parameters you need to set up this program allows a very easy setup even for, let's say, non-100% tightening experts. With our web-based interface called DEPRAG Cockpit Basic, the program creation is pretty simple and you can do it from any device, which means there is no special software needed which has to be installed on a specific PC. So let me summarize it. So clamp force control creates more constant preload force for self-tapping applications. It makes sure we have an electrical contact, which is very important for conductive connections, and it's pretty easy to set up. So let us switch topics now and have a look to the challenges we are facing in the assembly of battery packs. So the assembly of battery packs, due to the innovative high voltage components of an electric vehicle, present unseen challenges for production assembly. The integration of high voltage components demands radically new solutions. In addition, the issue of high voltage in the assembly process needs to be taken into account. Electrical vehicles have a significantly higher voltages, approximately up to 800 volt direct current. This requires higher safety measures for operators in the assembly process. During battery assembly, the cell module is assembled first. The individual battery cells are stacked, placed in the battery housing, and connected to the battery management system called BMS. In the next step, the current collector is connected to the power supply. The wiring is checked and the housing is closed. So subsequently, the power supply and contacts are connected before the finished modules are tested. The individual cell modules are fixed to a floor element via contact rails and assembled with fasteners. So finally, electronic boards and seals can be attached. Boris, so how do we from DEPRAG solve this challenge for the assembly of battery packs?
Yeah, so as Daniel mentioned, the high voltages are a significant concern. So DEPRAG has an installation concept. We're using special ceramics and synthetics parts. DEPRAG offers many variations of our screwdriving function modules, the SFM module. We offer this as an underfloor horizontal unit for pick and place. So along with the standard many executions, we've developed a system specifically for use for fastening components under power for up to 1000 volt, which can assemble with no danger to the EC servo screwdrivers or other sensitive machine components or control devices. These insulated SFMs can be offered as multi-spindle systems with MAS tooling for tight driving locations. So if you have zero clearance screw recesses in pockets or next to obstacles, we can access those, or traditional pick and drive solution for fasteners that simply cannot be blow fed. In addition, to this driving technology, the hardware of the SFM. As Daniel mentioned, we would commonly also join it together with our clamp force control system as a combined solution for battery assembly technology. So Daniel, go ahead and tell us a little bit about clean feed technology.
Sure. So, I mean, assembly of the battery pack. There is also one challenge, and that's technical cleanliness. Technical cleanliness has become increasingly significant in the recent years. So this is particularly important in the assembly of components for electromobility. So we at DEPRAG have various different approaches to make the process cleaner. But clean screws, from our point of view, have the greatest positive impact to the process. If we assume that the screws have been cleaned, feed systems which generate less abrasion can be used. So DEPRAG recommends the use of step feeders or sword feeders, like you can see in the left upper pictures. The gentle placement of the fastener means that the less abrasion is generated. In addition, with our so-called clean feed concept, we attach various vacuum sources to relevant points position in order to reduce particles. With the DEPRAG particle killer, which you can see on the third lower picture, the screw is cleaned again before the actual tightening process. In this way, we can also extract any debris from the feed hose. It is also possible to use a pick and place process. This means that the screw is shot into a pick nest and picked and processed via a vacuum sleeve in front of the screwdriver. The disadvantage here is the slightly higher cycle time, since the screwdriver has to be moved between the picking position and the tightening position. Screwdriving vertical from below, like you can see on the right picture, is also an option which prevents particles from falling onto the component, for example, a circuit board. With our eSFM, that's the module you can also see on the right picture, we have a screwdriving module with an electric feed stroke. We also have the option of making the coupling process between the bit and the screw gentler, which means less particle creation. The electronics mean that we can flexibly parameterize the speed and force with which the bit makes contact with the screw and optimally adjust it to your process. I mean, we try to eliminate as many contamination particles as possible with our clean feed concept. However, this still does not guarantee 100% technical cleanliness. Boris.
Okay, so thanks, Daniel. That was very informative. So to kind of summarize on those three subjects and why we chose those three subjects in combination, is these are all key features and hardware available to aid and assist in today's EV electronic component environment. The cleanliness can go together with the clamp force control, which joins together with battery assembly, EV modules, and for sure the overall picture of a complete solution. So the idea is not just one of these is typically required, but it's typically a combination of multiple of these processes that are joined together for a complete system. And DEPRAG is, the experts in supplying those complete solutions. Okay, I think that summarizes it for our points here. And as you guys develop questions, hopefully there's something that comes in at the end of our presentation here. You can also email us at engineering@DEPRAG USA. And if you would, note the subject of assembly webinar so we understand that you were tied into this and had this information. And also please join our LinkedIn, connect to us on LinkedIn and our other social media sites. So thank you.
All right. Well, thanks, gentlemen. Before we take questions, I would just like to invite everyone to take our survey after the webinar. Your feedback will help us improve our programs. All right, as usual, we do have questions coming in, so I'll get right to them. Here's our first one. Can insulated SFMs be supplied in all executions?
Daniel, I'll let you answer some of this technical questions here.
Sure, no problem. So yes, of course, we can supply them in all executions. We can supply it as a normal version, vertical from the top. We can supply it as let's say an underfloor version if you want to assemble a screw from below. We can supply it as a short version, a thin version. So all executions are possible due to our, let's say, standardization structure. We are pretty flexible and can deliver the systems in a pretty fast delivery time. Thanks.
Okay. Here's a question from Zach, and he asks, do your tools support open protocol?
So, Boris, let me answer this question here. Yes, it's at the moment not, but it's planned to have the open protocol on board. But in general, we just focus a bit more on the OPC-UA standard, so the new standard which is developed at the moment and standardized. So once the standard is there, we will have the OPC-UA protocol on board.
Okay. And Daniel, if you don't mind, just a quick follow-up. Could you maybe explain to some of our listeners who might not be familiar with that, what is OPC and Open Protocol? What is that all about?
So in general, I mean, OPC-UA is a new protocol to, let's say, a machine-to-machine protocol. So you are able to communicate with smart tools like a screwdriving system, but you are also able to command or to give commands to the system, or you are also able to receive replies from the system, like when we talk about screwdriving systems, then I mean, for example, tightening process data like torque, angle, depth, speed, and so on. So yeah, a new protocol, let's say.
Okay. All right. Well, here's a question about cleanliness. Does technical cleanliness require that a specific screw or screw manufacturer be used?
So, Boris, would you like to answer this question?
Yeah, so it's not a requirement necessarily for a particular screw manufacturer or a particular screw. There's certain screws which lend themselves more toward not creating particles just because of maybe the engagement of the bit versus the drive on the screw or the drive on the bit. One might run over the other a little bit more than creating particles. So there's certain drives which are more favorable. Torx drive is always a good drive for automation, and that tends to be where technical cleanliness tends to play a bigger role or related to the overall picture of assembly. It goes towards automation where there's some specific hardware when you tie it to manual assembly operations. And then from screw manufacturers, there's a couple of screw manufacturers that have geared up and prepared themselves for vacuum packed screws that have gone through a rigorous cleaning process in addition to their normal processes. And as you go towards the concept of clean feed for the hardware, it makes sense to also get in contact with one of the screw manufacturers that has preparations for this.
Okay. All right. Looks like we have time for one more question here. Is CFC or clamp force control, is that available on all of your screwdrivers?
So it's not available on all screwdriver technologies. For sure, it's a system that uses monitoring of the screwdriver's torque. So for sure, it doesn't fit into pneumatic screwdrivers or anything that doesn't have sensing technology. But beyond that, DEPRAG EC servo, so closed loop EC screwdrivers, clamp force control is available, and also our DEPRAG Plus series of screwdriving technology includes this as an option. So both current sensing and servo screwdrivers have that available, but it has to be, in general, it has to be a system that has the ability for monitoring torque and angle and so forth.
Okay. All right. Well, that is all the time we have for questions today. Please join me in thanking Boris and Daniel for their presentation, as well as our sponsor, DEPRAG. Folks, if you need screwdriving technology, you can. These guys are the best, so do check them out. If you've got additional questions or comments, don't hesitate to click the Email Us button on the console. Please visit webinars.assemblymag.com to view the recording of this presentation, as well as to get information about our upcoming events. We've got a webinar coming up next month on digital manufacturing that I think you're going to find interesting. And we also have archived webinars on robotics, automated assembly, machine vision, and press fit assembly. So do check those out. Thanks so much for your attention. We trust you've learned something today, and until next time, keep after it.